Welcome, everyone. Today it's my pleasure to introduce Dr. Sharad Goel, who is a professor of public policy at Harvard in the Kennedy School of Government. There he founded and co-directs the Computational Policy Lab. And there his work brings a computational perspective to a wide range of contemporary issues. Sharad has had a interesting career trajectory.
Interesting.
He began. He received his undergraduate degree at the University of Chicago. Then he received a PhD in applied math at Cornell. He also received his master's in computer science. Then he did a postdoc at Stanford and at USC, and decided that he wanted to join Yahoo Research and Microsoft Research after that. Later, he joined as faculty. He moved to Stanford, and he was faculty in the Department of Management, Science, and Engineering, where he also held appointments in computer science, sociology, and the law school. Through his work, he often contributes essays which have been published in the New York Times, the Boston Globe, the Washington Post, and many others, where he highlights issues such as policing, mass incarceration, algorithmic fairness, and many others. Today, he will discuss some of a very contemporary issue, which is AI in education, which I think we are all really interested in because we are educators. And so I'm excited to hear your work, and the floor is yours.
Okay.
Thanks.
Thanks for that. Thanks for the introduction. Thanks for helping out. You'll be neglected to say that the most important credential I have is we went to graduate school together. So that's so I'm going to tell you a little bit about some recent work that we're doing on the use and misuse of AI in education. I'll try to keep this interactive, so feel free to ask questions. We're not questions. And this is work led by two of my PhD students, Stabler. Is it? It's on. I'm not sure if it's loud. Is it loud?
Can you turn it up? Can you test that?
Hello? Hello?
Yeah.
Better? No. Louder? I just scream it out.
Closer to mouth.
Okay. Hello? Hello?
That's much better. Thank you.
Really close. Okay, does that work? No. Bad attire. Clothing malfunction. Oh no. Zip it up. Zip it up. Let's see if this works. Okay. No. No. Should have worn a suit.
I mean, I think it should be okay. If you project, then it'll be all right.
Okay. I can talk loudly.
Okay.
No. Can I just shout it out? No. That work?
Yeah, I think if you,
Okay.
if you project,
I'm just gonna
okay.
go
Sorry
old
about
school.
that.
Sorry. I'll wear better clothes next time. So this is joint work with that was led by two of my PhD students, Hans Gabler in stats and Calvin Isley at the Kennedy School. So the first part, I want to start with the misuse of AI, and we're going to investigate the use of AI at a large public policy program, and particularly use by applicants for writing the essays that they submit as part of the application process. So I'll note that the essays, as you might guess, are kind of the standard things they write about what why they want to study policy, what is their career path, then all the usual things. And I'll also say that AI is explicitly prohibited. And so the statement, all essays must be written without the use of generative AI, is kind of boldface on the application. So I'm gonna talk mostly descriptively about this. I'm gonna try not to take a normative position, but can come back briefly if you know. So this is a little bit of the misuse is it's literally true in that the use that we are going to see violates policy, but I'm not taking a normative stance personally on whether or not this should be a violation. So just to be clear. So to detect AI usage, we're going to be using one of these popular detectors, GPT-0. Heard of them? We use it. Pangram is another popular one. The results are robust across detectors, so I'm just going to talk about GPT-0 things. Keep things straightforward. So the first thing we do is we literally just take all of these applications. We have like, 13,000 applications. We just like run all of them through the detector. And we see, well, ChatGPT was released in November 2022. Pre-ChatGPT, we see basically no detections. That's good. And then after ChatGPT, we see a lot of detections. And in fact, the majority of applications we detect substantial AI use. And the policy is no AI use. The majority of applications in the most recent cycle indicate AI use. And for international applicants, we see 70%. And so it's very, very common. And this is probably old news to all the students here, because there's statistically a reasonably good chance you're also using these things in your applications. I'm not being judgy. I swear. I use AI all the time. So this, in some ways was like surprising. We're going to have a pool going, office pool going of how much AI use are we going to see. I was actually wrong about this. Students were like, everybody uses it. I was like, no, but it says don't use it. Yeah, it's just like, obviously. So they were like, what's the application pool? The entire, the number that everyone who's applied over this like 10-year period to Harvard, to a large process. Large process. Okay. So the so it's a lot. And so I was actually wrong about a couple of things here. So the first thing I was wrong about is the magnitude that this was. I didn't realize, again, me being naive, I didn't realize how much AI use was actually happening in the world. And the second thing that I was wrong about is that these detectors are actually quite good. Like they used to maybe not be so good, and you have to be careful about it. But we basically see 0 false positives here. And we're picking up a lot of usage. And so these are surprisingly good. We'll come back to that point at the end. But originally my intuition was that these wouldn't actually be that good, but for subtle reasons, it turned out to be quite good. Now I'm talking about the ones that we actually detected. And we don't have a lot of false positives. That's something that we can test more or less by looking at check. Not a lot of false positives, about 1%. False negatives are very hard to get on. I mean, some of this is like range restriction. We're only seeing more than half of applicants are getting triggered and flagged. And so we can't be missing that much. But we're probably missing some. And so that's just, like to say the vast majority of applicants are probably using this in their writing notices. Okay, so the next question. So a lot of applicants use. The next question is, why are they using it? Does it actually improve the quality of the essay? Is it just like making it faster? It makes it easier. It's like, what is it actually doing? And so we wanted to look in particular about, how did the quality causally improve as a function of these types of things. So here, the first thing, we need a measure of quality. And so we asked a bunch of the admissions officers to rate a bunch of essays, and then we trained the AI to mimic what the admissions officers do. And when we do that, we get pretty good relationship. And so every essay was rated by some admissions officer. He looked at, this is like the composite score. This is like basically the ground truth, how good these essays are by the professional admissions officers. And then we trained the AI. So now we have this on this relatively small set that we validated. But once we have this model, we can apply it across our entire pool of roughly 50,000 applications, which is like 50,000. Okay, so we did this, and we see here, let me start here with international. So the story for domestic and international is quite different. But for international applicants in particular, this is, so if you look at the overall rating, that's in the blue here, we see a huge jump after ChatGPT is introduced. And so, this is about a half a standard deviation. And so it's a huge quality jump when ChatGPT was introduced. And remember, not everybody is using ChatGPT to begin, especially here, it is like not that many people. Once you look at this period, you're seeing like gigantic jumps. And so where is that overall quality bump coming from? Most of it is coming from the mechanical quality. So this is like just like the narrow sentence structure, grammar, all of these types of mechanical aspects of writing. That's where most of the quality jump is coming. But we also see a little bit of a bump in the substantive quality. And so the substantive quality is Are you using detailed examples, personal examples? Is it like vivid storytelling? You know, these what we associate with like good writing, not just the chemical qualities, but the actual good substance of the writing. And so we see again this huge jump. So it does seem to dramatically improve the quality of the writing, the introduction of these types of tools. For domestic applicants, it's a more subtle story that there does seem to be some improvement in the quality, but as you might expect, you know, the mechanical quality is probably not going to be that much for domestic applicants. This is their comparative advantage here, and so we, you know, understandably, I think don't see this. Okay, so this again, story so far, a lot of people are using AI. It really does seem like AI is improving the quality of the writing. But then we found something funny, that conditional on everything else we see in the application, and we see everything. It's like this is the full dossier that applicants are submitting. So it's to be like, you know, these 50-page, you know, packets of information. You see it all. Conditional on all of that, we see that students who use AI seem to get in less often. But everything is better. It's like conditional on everything. You know, this is what we're trying to adjust for. It's like, you know, the same test scores, the same like recommendations, all of these types of things. And we know their essays, if you use AI, your essays are better on average, but they're still less likely to get admitted into the program. And so this was like kind of puzzling for us. It was like, why, you know, how is it even possible that this is the case? And then we realized, well, okay, why can we even detect? So this is I'm going to do a little exercise with you all. So one of these two essays is written by, these are, so one of them is a real essay submitted to Harvard. Another is an AI version of that essay that we prompted a model to say. So I'm going to ask you to read this, just take a minute, read it, and then I'm going to ask you to vote in a second. So look at this A or B, which one do you think was written by AI? So don't say it out loud, but just like keep it in your mind, and I'm gonna ask you to vote. Okay, you need more time or are we good? Okay, time to vote. So go ahead and scan this code, or you can go to polyd.com/Goel. And then vote. Which one do you think was AI generated? And ready? Who's feeling confident? Who knows the answer? Who feels like they know the answer? You know the answer? What do you, yeah? You're getting called out.
I'm volunteering my.
Oh, no. It feels like they are like convinced they know the answer. No,
I will say we are convinced we.
okay, what do you think?
We think A was written.
You are a good detective. Congratulations. Congratulations. So this is pretty good. This is actually an obvious to a detector. This is an obvious example. So I gave you an easy one. Too bad on your side. But this is a pretty clear example of that. But you know, it's still like kind of hard for humans to figure out what exactly is AI, what is not. But you can tell. And this is like part of why detectors work, is that they're like clues in these essays. So I'm curious here, why was it so obvious to you?
The M dashes.
Okay, so that was a giveaway here. That was intentional plans. But the M dash, the notorious M dash, I actually had to like get rid of M dashes in my own writing for fear that people are going to flag it as AI. So I had to like humanize my own human writing. But yeah, and so this is one of the tells. But what's interesting about it is that, you know, before my mental model was like AI is just like the writing is like very good. It's just like good. It's like, you know, superhuman. It's like clearer to me. It's clearer than me. It's just like good. So how can you tell the difference between AI writing and human writing? It's just like a good version of human writing. But really, that's the wrong mental model. Really, you should go back to the like stylometry days of figuring out who has written what. And it's like among good authors, they still have ways that they write. And every AI model has a way that it writes. The M dash is a notorious example of this, but just like word choice, this like rule of threes that shows up a lot. There's like all sorts of telltale signs for a style of writing. So even if it is objectively better, right? That if you don't know that it's AI on average gets higher ratings than non-AI writing, but there's still a style to AI writing that the detectives can pick up on, and also we humans can pick up. So once we like understood this, we did we asked the admissions officers, tell us, like go through and rate a bunch of different essays and tell us what you think the likelihood is that this is AI or not. No detectors allowed. They're just like doing this, they're just like we're adding in these things, and they're like rating on a scale from 1 to 6, from like very likely human to very likely AI. They're trying to see, can they figure it out? And they're pretty good. They're like kind of like you all. Here it's like here when we're saying that it's almost certainly AI, about 70-80% of those are in fact AI. And so they're pretty good at this particular test. And so this seems to explain what is going on. If the admissions officers can detect AI and they don't like it, like even if it is better, like even if it's objectively better quality writing, they don't like it. And that might be fine. Again, it violates policy, but it is, and so maybe they are like intentionally in interviews, they tell us like, oh, it's like, I don't want to see AI writing, we want to see human writing. And it's not that it's bad writing, it is just AI writing, and that is not the type of application we want. And so this was probably by staff telling us this is part of this. Okay, so again, lots of essays are AI written. Almost certainly the number is going to keep on going up until I think it's going to be 100% before too long. The AI written essays are generally better by the same criteria that the admissions officers like using to evaluate the writing, but they're distinctive. They have a distinctive AI quality that people can identify and have. Now, there's this big question of, is this normatively appropriate? I don't know. Like, is this actually what our policy should be? And remember, there is this, these types of policies have differential impacts in different groups. International students by far more likely to use AI than domestic students, about twice as likely to use AI. And much of the quality improvement was in the grammatical, mechanical aspects of writing. So is that something that we want to be selecting students on? Or is it okay in that context to be? And I don't know. I mean, I think it's a big question. It depends on what your goals are as a program, what we are trying to accomplish, but also leave it back. So most programs are explicitly banning the use of AI in these applications, and also most students are ignoring that. And so this is like, in my mind, at least a funny place to be. And so we can be more harsh, we can a lot of it, but we can also be more lenient and say this is the appropriate use in this. So I'll leave that as an open question for folks to think about. These are questions that I have to try to figure out what is the right policy that we should have. Okay, so that was part one of saying this is the quote unquote misuse of AI in admissions. It's descriptively put in the final policy. So now I want to say, how can we use AI to improve admissions decisions? And this is so I'm gonna go back and I tell this story without talking about AI for the first 10 minutes. And I'm gonna tell the story about this debate, this long-standing debate on test scores in informing college and graduate school admissions. And so probably many of you know, this is something that has really been a decades-long debate. So, over the use of SAT, ACT, GRE, standardized test scores in informing these college and graduate school admissions. And proponents argue the standardized tests are useful, in fact, critical signal of academic quality, and it's not something that can be replaced by anything else. The unique signal of academic quality. That's on one side of the debate. The other side of the debate argues that this is, these are burdensome, that they are that they're biased, that they're excluding populations from entering these institutions. And so again, this is like been a long standing debate. But for the most part, the test score proponents have, and so it's like we've had basically for the last half century, we've had large scale standardized testing as the default apparatus of university admissions. Okay, so test score and conflates have really won this so far. So then COVID happened. And COVID really upended everything, and a lot of institutions decided that they're going to eliminate standardized testing. In part because it was just like logistically difficult for students to get to testing center and to do this, and it's a lot going on. We just like got rid of standardized testing, paused it. But then the pandemic passed, and a lot of institutions still like have those test optional policies. Some even eliminate test. And I think this was likely in response to this like growing backlash to testing. And this was an opportunity to just like scale back all of those. And so even though the proponents of testing had really won, and there was a lot of this testing happening, there was still this like backlash of people who were very deeply upset about the use of testing. Once it wasn't formally a part of admission even for a couple of years, the nominal cause of this had passed, the COVID pandemic, but people are like, it's just easier to continue on this path of saying we don't need everything is like okay. And so in this like brief period, the opponents of testing had like pulled ahead of this race. But then there was a backlash to the backlash. And you saw all of these splashy articles. This is one from the New York Times, but we're all over the place. They're saying this like misguided war on the SAT. And here there's this resurgence of the proponents of testing coming out with new research and bolstering old research of saying it's like, look, tests are important. It's like this is a uniquely credible signal of academic preparation. And in fact, it helps these populations that a lot of folks are worried about. And so this was this whole line. This is what these types of splashy articles are claiming. And I would say largely they got the research. So in a descriptive sense again, of saying it's like, what did the research say? So the research finds almost universally that predictions of future outcomes, like future grades or future employment outcomes, any of these types of things, were substantially improved if you use standardized test scores. Okay, and so this was like a near universal finding in the literature. And it wasn't just like a little, it was like a lot. Like the improvement in predictive quality was like quite a lot. And so now, again, this is the backlash to the backlash. And here is sort of a standard plot that shows up in this literature. This is pulled from the New York Times article, but this itself pulled from an academic paper. And you see something like this, where you have versions of these plots where you have test score on the horizontal axis, and you have future. This is for high schoolers, and you have the future college GPA here on the vertical axis. You see this very strong relationship where about a 50 point increase in SAT, for example, corresponds to a 0.1 increase in college. Okay, and so this predictive sense, and this in particular, the claim is that this is much more predictive than high school GPA. Okay, so this was the type of evidence that was marshaled in favor of standardizing. Okay, so university administrators really paid attention to this backlash to the backlash. And here is a statement from Dartmouth president. And for my new research, Dartmouth will reactivate standardized testing requirement for undergraduate admission. The research was exactly the types of things that I showed you a minute ago. At Harvard, our own dean of FAS, saying standardized tests are a means for all students, regardless of their background and life experience, to provide information that is predictive of success in college and beyond. So mirroring a lot of this work, the university administrators are saying, okay, it's like we now understand this research, and this it really is critical to making submissions decisions, and so we are going to reinstate it. So I think by my count, 7 of 8 of the IVs are now either using standardized tests for college admissions or plan to in the upcoming cycle. I think Columbia may be the only one that's okay, so that is the state of affairs as of really the last year or two. This has all been playing out in the last year or two. Now, what we're going to argue is that in fact there's deep reasons to be concerned about these conclusions because of 2 statistical errors, pretty subtle statistical errors that are happening. So the first is that predictions are being conflated with decisions. And that's a subtle error. I'm going to walk through that, but they're really different. Like when you hear predictions and decisions, they sound kind of the same. It's like when I tell you, oh, test scores are really predictive of future success, it seems obvious that we should use them to inform admissions decisions, right? That, this just kind of comes out in one breath. They're predictive, therefore we should use them to select students. That seems like not a big leap of logic. In fact, it's a huge leap of logic. I'm going to unpack the meaning. The second is relatively weak baselines. And part of this is in a pre-AI world, it was hard to extract the type of signals that humans regularly. So things like transcripts, letters of recommendation, essays, all of the rich information that is in an application packet that a student actually submits, that was largely ignored. And so the horse race was between GPA and GPA plus test scores. And that's a really hobbled horse race. And it's certainly not the race that admissions officers engage in when they, as humans, are trying to evaluate how likely an applicant is to succeed at their institution. So now in our AI world, we can do it. And so once you adjust for both of these, we actually find that test scores provide relatively little value to admissions decisions, at least in this context that yeah, and so I'm going to start with the same thing, same pool of applicants. We're going to look at about 10 years of applications to this policy score. And the reason you'll see their theoretical reasons for these results generalized, but the empirical results are going to be exclusively for this group of contents. Please. Yeah, so I'm unpack. So there are two things that I'm going to try to unpack. The first is conflating predictions with decisions, and the second is weakness. And I'm gonna spend a little bit of time on both. Yeah. Yeah, so I'm gonna replicate the standard analysis. So it is interesting. It's not usually framed this way, but really this is the same issue that comes up with prediction versus causation. This is essentially the same issue that's coming up, but we're going to give a very specific solution.
Yeah, so in terms of extrapolation, the Friedman and the Trump papers, looking at undergraduates,
Yeah. Yeah. So hold that thought and see if you're persuaded by here. Okay, so yeah, the first thing we're going to do is we're going to try to mimic the past results. And to this point, we want to know, would we conclude? This is a different context than what a lot of people have looked at. Certainly a lot of people look at graduate admissions and have made the same GRE argument. In fact, at Kennedy School, we also went test option during COVID years, and then we went back to test required. And so people are making this at all levels, not just at the college level, but also the graduate school level. But the first point is, would we draw the same conclusion if we use the same methods that people are using when they study undergraduate admissions? Would we have made the same conclusion, reached the same conclusion using those methods on our paper? If not, then we're in fundamentally different contexts. If we do see that, then at least it suggests that it is related. Okay, so what is the standard thing that we're going to do here? We're going to predict first year quantitative grades, statistics in statistics and economics. This is one of the reasons why people are looking at with GRE scores is in these quantitative courses, how well are people doing? That's what it's generally need to be a strong predictor of. And we're gonna run this force race between two models. Our GRE blind model that only uses GPA and school strength. So it's like the strength of the college they went to. GPAs mean different things at different institutions, and so we're going to adjust with the strength of that institution. And we're going to look at a GRE aware model that additionally includes GRE scores. So our GRE blind model and our GRE aware model. Okay, so the first thing we notice is we can more or less replicate in this new context exactly the type of evidence that people are marshaling for this argument in the undergraduate and broadly in this domain. And so here we see that about a 4-point increase in GRE scores corresponds to about a 0.1 increase in GPA. This is after adjusting for undergraduate GPA. And so we adjust for GPA, and we're saying the marginal benefit of GRE looks to be like pretty predictive. In fact, it is predictive. And there's like this, you can look at this, you can also look at something like the R squared. The R squared for the GRE blind model is 0.18, and it's about double for the GRE aware model. So really, that's about the same magnitude that you see in the literature about that is out. Or looking at other. So it's a pretty robust finding that in fact, GRE scores, test scores are quite predictive and a usual metric for predicting future outcomes. Yeah, that is exactly replicating the literature that is out there. This is the core argument which has promoted the use of testing. Okay, so far, everything I told you is accurate. We agree with the literature, we're finding that. But now what I'm arguing next is in fact, none of that matters in the role that admissions officers actually face. And so why is that? So what is the problem that admissions officers actually face is they are trying to select an academically qualified cohort of students, right? That is the only thing they're doing, right? They are making a binary decision for every applicant accept or reject. And they're saying it's like, who should we admit? And that is the thing that they're doing. They're not intending, they don't care so much about squared. They don't even care about this like marginal predictive performance. At the end of the day, they are trying to assemble a class of talented students, the pie choose. Right? That is the decision theoretic problem that admissions officers face. Okay, so why does predictive performance not directly relate to that decision problem that I just stated? And it's a subtle reason. And so first, I'm going to show you some. First, I'm going to kind of walk you through the exercise of actually modeling what that decision theoretic problem is. And then I'm going to back up and show you a little bit of theory for why how we can directly connect these two, the predictions of these. So first, let's model what they're actually trying to do. So there's a constraint, right? They have a fixed number of seats. And so we're going to say it's an institution, something like 20% of applicants are going to end up being admitted to the school. Right? Everything I say generalizes to 10%, 30%, but let's just pick 20%. That's like a big canonical, reasonably competitive, but not ultra competitive. So, okay, and we are going to do a horse race again between the GRE blind and the GRE aware predictive models, and we're going to look at the strength of the resulting class that we would achieve under those models. So in particular, what we're going to do, we have our two models. We're going to predict GPA, right? Both the models predict future GPA. Then we're going to select the top 20% of applicants under each of those models. And then we're going to look at the strength of the resulting pool of applicants. And I'm going to give you one summary statistic right now, but we're going to look at others later, of just the average GPA of those selected. Okay, so this is the problem that admissions officers actually face. Like they might be making these predictions in their head. At the end of the day, they draw a threshold and say, these people are in, these people are out. And now I'm going to look at the strength of that cohort of people who are in. That's the only thing that they fundamentally should care about, at least it's taking this consequential. Okay, so what are we going to do? So one issue here in this story, it is hard to know the counterfactual about what had happened had you admitted a student who actually in reality did not admit. Right? We don't see it. So if I say, oh, you should admit this student over there, if they never came, if they were never even admitted, we don't know counterfactually what their belief is. So there are a few ways we can handle this. We're going to take three strategies. So the first is we can try to infer the grades for everybody who in the pool based on all the very, very rich information that we have about all. That's one. The second, but you might worry about some kind of model specification, limited variable bias, you might worry about these types of things. The second is we're going to restrict to the pool of matriculants. And we're going to say some set of people, a few thousand people actually attended the institution during this time period. And so we are going to say, look, we run this analysis on those matriculants and pretend that we are selecting from that pool of people. And that, in fact, is the pool that most of the literature looks at because we see the outputs. Now, there's something funny about that because that's not actually the real pool. It's like a much more homogeneous pool of people than the actual pool. So it seems your results a little bit. But that's one other thing we can do. The last thing we can do is we're going to look at people who have at least a 10% estimated probability of being admitted, and then restrict our inference to that population because that's the part of the population where you have reasonable confidence in. It's like if they're super out of distribution, like if this person never would have been admitted and they never would come. Well, we don't know what's going to happen to that person. We're really leaning on the model to tell us what's going to happen to the person. People who have a reasonable chance of being admitted, over the years, somebody like them was probably admitted. So we can base our estimates on those types of people who are actually. So it turns out all three of these strategies produce the same result. And so for simplicity, again, I'm going to talk about number one, but all three of them produce the same things. Okay, so when we run this, what we find is that jury blind policy yields an average GPA of the cohort of 3.58. The jury aware policy is 3.6. So that's a gap of 0.05 GPA. So this is not zero. It's not, entirely negligible, but I would say it's smaller than one might expect. So another way of thinking about this is a half a grade point, a half a letter grade difference for 10% of your population. And so here, remember, the R squared was twice as high for the GRE aware policy than the GRE blind policy. But once you look at the strength of the cohort that was admitted, it's actually a pretty small 0.05. Now it's not nothing, but I think it's smaller than I would have expected. And I think smaller than what much of the decision making around this would likely be. It's hard to know exactly what people are considering, but I think this is a relatively small gap. Okay, so why is this happening? So it turns out to be a very simple reason for why this gap, this 0.05, is pretty small relative to the R squared differences in the predicted quality differences that we're taking. So I'm going to show you two pictures. So the first is, this is under my GRE model, on my GRE aware model. This is my predicted GPA for every student in the applicant pool. So what does the admissions officer do? They draw a line, a threshold, and they say, okay, I'm going to admit these folks and I'm going to reject those folks. Okay, and 20% of applicants are here, 80% of applicants are over there, and that is their decision. Right. All they have to do is estimate that quantitative GPA, and then the rest of their job is easy because they draw the threshold and they push people to one side and the other. Question? Yeah, so okay, so this is a good point. So everything I'm saying right now, I am stacking the deck in favor of test groups. So why is that? Because here we're saying the only thing the utility function for the admissions officer is quantitative GPA. Test scores are best at that thing. So if instead we were to look at the holistic application and like this multifaceted objective function that admissions officers likely have, everything is going to shrink. And so here I'm just really stacking the deck in favor of test scores by only focusing on the quantitative GPA. Please. Yeah, so it turns out that the school we're looking at, there is relatively little. Yeah, and so here you can already see this by the the numbers here. So this is again, this is not college, this is not the average, but this is by modern standards, this is not terrible. So only about 15% of students get A's in this program. It's true that not a lot of students get A-, but not that many students. Okay, so now that again is what's happening under the GRE aware. So if we switch to the GRE blind model, what is going to happen? Well, some of these students are going to get admitted to the right of the threshold. Those are the ones in blue, but also some of the students to the left of the threshold are going to get admitted. So why is that? Because the GRE blind model is making decisions based on its own calculation of top 20%. And so the GRE blind model's top 20% is not guaranteed to be the same as the GRE aware model's top 20%. But in fact, most of the time they agree. In 90% of cases, the GRE blind model and the GRE aware model make the exact same decisions because they're clear. They're far from the threshold. And so it's like a stellar student and a student who's likely going to struggle. Both models, GRE aware model or GRE blind model, can correctly identify. So about 90% of the time, all the decisions are the exact same. Now, when there are differences, they're right around the threshold. And so here we're swapping somebody slightly to the right for someone slightly to the left. And here, by definition, because they're close to the threshold, their GPAs are not going to differ that much. And so here are the two facts that are driving this result is that first, the vast majority of decisions are the same. Even though there's a big predictive difference between the models, the vast majority of decisions are going to be the same. And when there are differences, those students are going to be very similar to one because they're exactly the ones that are the hard cases. Like no one fights about the students, it's the tails of the distribution. The disagreements are going to be at the threshold. And that's the exact same success. Okay, so big predictive difference, not very much decision theoretic difference. Okay, so now I'm going to just formalize this. I swear this is the only math I know. It's like 4:30 in the afternoon. But I'm going to show you a very, very simple analytical result that helps explain what is going on. So here, let's just assume we have we can model grades and predictions. Actual grades and predictions is jointly normal. That's a relatively mild assumption that is largely satisfied in the data. And now what is going to happen here? I'm going to explain the difference here. This is the thing that I just talked about. This is like the 0.05 gap that I just showed you. This thing, select people who are in the top 20% under one predictive model, look at their average GPA. That's a conditional GPA of people who are admitted, who are above the threshold by one model. I'm gonna look at the exact same thing for my other model. So this is my baseline model. And I say, what is the average GPA difference between these two models that have competing predictions of how well a student's gonna do? And it turns out that this can exactly be expressed as a product of three terms. So what are the three terms? The first term is a standard deviation of GPA in the applicant pool. This is just a scaling factor. Like there's no real content to it. It's just like saying, essentially it's accounting for like grading. It's like, what is the scale that we're talking? Well, we have a 4-0 scale, a 10-point scale, and what is the scale we're talking? So really it's just a scaling factor. The second, this is the interesting thing. This is capturing the difference in predictive quality between the two models. And so rho here is a square root of R squared. Right, so we have the R squared that I was telling you before. The rho here is a square root of that. So again, it's just a correlation between the predictions and the actual values. And it's like the very standard measure of model fit. And then here, this is a factor, a constant factor that depends on the emissions rate. And so this is roughly 2 across a range of values. And so it ranges from about like 1.5 for 20% to about 2.5 if you're at 5%. Like roughly, it's 2 across a reasonable range. Okay, so that's it. That's exactly the how we can decompose the difference in quality with the actual prediction. Like this is the prediction that most of the literature has been looking at, implicitly at least, and this is the thing that is policy relevant. And we're saying, in fact, these are related, but you really have to account for these other terms. And when we look at our theoretical calculation, this is the dotted line, and we look at the empirical simulations, we see that they match like quite well. Not perfectly, but they match pretty well. And in particular, the we're really seeing across this whole range, we see relatively small. The model is predicting relatively small increases in gaps in quality, which is exactly what we see. And so this is one of the reasons why it's likely that this type of result will generalize to other settings, because this is more or less universal. Like joint normality is, I would say, pretty mild assumption across contexts. The big question is how big is that predictive gap? And it is possible, although I think personally unlikely, that in the undergraduate context, you see huge predictive gaps between like an SAT model and a non-SAT model. But again, it's an empirical question, but it's not obviously why that would be. Okay, so far I addressed the main issue, just like inflation of prediction with decision in this problem. And so now I want to address the second one of using a stronger base. So the models that we've talked about so far really use GPA, some other like school strength. In the literature, sometimes they use demographics, but like pretty parsimonious models that are being used. And largely that is because I think that's because that is what's been easily accessible. But in reality, admissions officers use a lot of information. They use transcripts, they use resumes, they use letters of recommendation, they use essays, all of this stuff, like a huge thing, the thing that stresses out students, all of that is getting thrown away when we're doing these types of predictions. But now we can actually pull all this stuff together. And so, for example, we can now look at, it's like, what was your grade, your microeconomics grade in undergraduate? Did you take a microeconomics class? Did you take 3 economics classes? And what were those grades? So that is something that we can now extract at scale using modern computer vision and large language. And so again, this is only really possible to do reliably and cheaply over the last year or so, but now it is something that we can. So now we're going to repeat all this analysis, but really using the full set of information that admissions officers have at the time of making that decision. And so what do we find here? We find now the jury blind model uses a GPA of 3.62. As you're aware, is 3.65. So here, so again, if there's a little bit of a rounding happening here, but it's a 0.03 GPA points gap that you're getting, the boost that you're getting with using GREs. Before it was 0.05. Okay, so now this really is getting shrunk to a pretty small difference that we're seeing. Now I was showing you averages. In fact, everything here generalizes to other outcomes. Here I'm going to show you the full distribution of grades. And we have, we have here again, it's like the with GRE is in red, without GRE is in blue. And we see it's not like one of our worries was the average might be the same, but the tails might be really different. And this is something that a lot of instructors worry about. It's like, if you get a few more A's, that's not a big deal. If you get, more B minuses, or C's, or people who fail the course, that really is a big deal. It's bad for the student, it's bad for the institution. But when we do this, we actually see that these are largely the same across the distribution. So the average doesn't seem like it is really messing up our evaluation. The second thing that people care about a lot in this literature is, there is this kind of implicit claim that the composition of the class is going to be hurt on demographic dimensions. And so in particular, without test scores, the claim goes that you might miss that super talented student who's at an institution that is simply, that where you don't see a lot of students from, and so you're going to downrate that. Okay, and so you just think about one way we talk about it in terms like the Ramanujan effect. You're like, this is like a genius, but nobody knows because operating in a part of the world in the context where there are not a lot of folks like. And so this was like the real worry. We're saying like maybe the composition of the class actually differs because without GREs, maybe we only pick people from super selective institutions because those are the places where we readily can estimate what they're going to do, and we're going to admit all those people, and then we're going to reject the people from the low-ranked institutions, even because who we would have admitted because they had high tests. Like that is how the story goes. It turns out that that's not the case empirically. That regardless of whether or not, so this is the undergrad institution that the students are coming from, the rank and quintile. So these are the most selective institutions. These are the institutions that are the least selective. So we're just dividing through the quintiles, and we see with or without GRE scores, we're getting about the same distribution of students across this selectivity spectrum. I'm showing you this for undergraduate institution selectivity. The same pattern told if we look at things like race, if we look at gender, or if we look at international status. So, and why is this happening? Because basically all the decisions are the same, right? That is the punchline of the story, that even though the predictive gaps are big, when the decisions are basically the same, nothing else can change in the composition of places.
That with a, sorry, first quintile.
Yeah.
That's just significant.
It's not. So you can see, so it's a little bit hard to see from there. Here are the error bars of this, and you have to be a little bit, yeah. So these are all like really small gaps. Okay, so, again, just like summarizing what we found here is that the literature is largely focused on prediction. And it's very easy to say the predictive quality of models is better with information X. Therefore, it is critical that we use that improved model to make our decisions. But the logic there is quite subtle and does not quite follow through. And here I'm gonna use this quote from the president of Dartmouth, who says SAT and ACTs can be especially helpful in identifying students from less resource backgrounds who succeed at Dartmouth. test scores are an important predictor of the student's success in Dartmouth's curriculum. Right, the same press release. Now, one part of this sentence is true, that test scores are an important predictor, right? That is totally true. That's what we find. That's what the literature found. Identifying is a decision problem, and that is not, it does not seem. So again, it's like casual conflation of prediction and decision, which is likely the thing that is driving this backlash to backlash and the new university policy that we're seeing is, I think, precisely for making the statistical error. Now, where does this leave us? You know, should we use test scores in admissions? And the short answer is I don't know, right? And why don't I know? Because I like really pointed out what I think of as an error, like a logical error, statistical error in analysis that has been done. I think hopefully I persuaded you that that is true. I think what is less clear is what is going to happen if we do the right empirical analysis in these types of settings. And we don't know. It could plausibly be the case that there really are big gaps in settings where universities are using test scores in favor of not using test scores. But I would say the evidence that has been brought to bear to this question is largely not compelling for making those types of policy choices. So again, it's an argument of faulty logic, not an argument that the actual decision was problematic. That's very hard to know without doing the analysis itself. But still, I would say, even if we think about our context, they're still not entirely clear. So even in our context, that test scores do seem to improve decisions a little bit. And so if there's no cost, then you may as well use it. Right? If there's literally, if I can eke out that 0.03 GPA point improvement in the quality of my class, and literally there's no cost, I was like, why? I should do it. Right. So the real question is, is there a cost? Logistical, financial, social. Maybe there is a cost. Maybe it's even smaller than the benefit. So you should still use it, right? That's something that we have to consider. But if there are significant costs to using these tests, and at least some people believe that to be the case, then I think that's a reason to really revisit these admissions requirements, these test requirements, and perhaps back off of the backlash to the backlash. So maybe there will be a backlash to the backlash to the backlash. We'll see. Okay, I'll end the conversation.
Thank you so much. This is fascinating. One observation and then maybe a theory and a question. First, going back to one of your very first slides about this to after COVID. So COVID hits, colleges and universities largely become test optional. And I think the premise was that some did not go back to requirement testing. That is, they remain test optional, but some on a sort of a principle basis that they didn't believe in standardized testing. I think, in fact, many of them remain test optional because they liked the boost in application volume they got. And it wasn't about the principle of whether they liked the SAT or not.
Yeah.
They got their cake and could eat it too.
Yeah.
They had all of the students who would normally apply with standardized testing, plus 25% more who applied without standardized testing, which meant their admit rates went down, which meant that it made them look better. So I don't know.
There's another thing we should talk about. For another time.
So I don't know that those decisions were all based on some,
100% agree. Yeah.
we believe in test optional. It was like we believe in lower rate acceptance rates.
Yeah.
The second is I wonder, and this is just a theory, and I wonder how. I think you talk about this a little bit at the end, and the theory is that I think there's potentially more variation among secondary schools, high schools, than there is colleges and universities who are applying to this one particular graduate program on public policy. And so, like, looking across the country, looking just at Providence, there is a massive difference between Hope High School, a Providence Public School, and Moses Brown, even though they're 2 blocks away.
Yep.
They are not the same.
Yeah.
Even though they're both high schools in Providence.
Yep.
But applying to this graduate program in public policy, whether you went to Dartmouth or the University of Michigan, you got a really good education, even though those are 2 very different schools. So it's just a theory that there's more variation among secondary schools than the colleges.
Which should help you.
Studies.
If that is true, that should strictly help you, and the gap should be even smaller in the variation. The real worry is there's not a variation.
Well, and I think, so my theory though is that variation at the high school level means that there's greater variation in test scores, which is why there's probably a greater predictability at the high school level.
But if it co-varies with things you can observe, the absence of test scores, you still get them. Right, so this is really the question, and it's very hard to think about these conditional correlations. But the fact that those test scores are super correlated with some outcome, it's like that is not the thing that's relevant. What is relevant is the marginal conditional correlation after we've adjusted for instance. And so wide variation in and of itself is not decision relevant. It is only, is it uniquely variable? Right, so that's like the something. Again, I'm not saying that this has to hold in these other contexts, but I'm saying that based on what you're saying, I would have a weak fire that this result will transfer to this other setting, but I'm sort of not like. And the other thing to say, so like let's, and this I think is the important question, is it, think about what the dossier looks like for a high school. And so how can we vary, how can we tell the difference between applicants without testing? Right, the claim is you can't tell, right? The claim is that I've like selected these students from 2 different high schools. The only way I can tell the difference between them is because one got a really good SAT score. But what do we actually know about these students? We know the courses they took, we know the AP courses they took, we know, we know in many cases the actual AP test scores. It's still funny because when people are talking about standardized testing, they're probably not talking about getting rid of AP testing. That's like another thing that has a whole industry of players. And so really it's like now we know their AP test scores, we know where they're like captain of like 17 different clubs and also captain of the football team. It's like all of this stuff is there that largely has been ignored because it's been hard to take out in the absence of AI. But I would say that we really can tell the difference between qualified and unqualified students in the absence of test scores. And the last thing I'll note here that kind of shapes my fire is during the COVID years, everything was kind of different, but we didn't admit students as these selected institutions that were really just like totally out of district. Like if we believe this, so nobody had these test scores, so a lot of students didn't have these test scores. If we really thought that was like a critical signal, we would expect like all of a sudden the like classes just collapse. And I know everything was different, so it's like it's hard to know. Like grading became more lenient, and like people were no, so everything's kind of different. But it wasn't that all of a sudden, if you look at the composition of those classes, that they look dramatically different. It wasn't like this is a random sample of the pool. It actually looked those classes up pretty close to the classes that we normally get when we have this. Again, suggesting that admissions officers really can discern the difference, even when we go. Yeah, but this is all just like me hypothesizing, theorizing. And I completely admit that we don't know until we know. And so really, I would like to run the information because if anyone would like to share. Contact me on my number slides. Yes. Well, thanks. Was that the last, was there the third one or was that?
Oh, no, I just, I think like in America, high schools are just so completely different based on the resources available to them. That even if you took 2 students with the same curriculum and the same grades,
Yeah.
their test scores would be very different, their outcomes would be
Yeah. But you adjust for the school strength in all these testing. And so that's where a little bit of innovation. Yes.
Thank you for the really nice talk. I'll preface this with this is like outside my domain of expertise for sure. I was intrigued.
Mine too. I just
Yeah. I was intrigued by the first part of the talk about talking about the influence of AI from the applicant's perspective. But I'm just curious, is there any, I guess, use of AI on the admissions perspective? I can just imagine a naive world where admissions officers flood it and there's initial cutoffs, I assume, grades, and how does that impact? Does AI see an AI, essay that, oh, this is great.
Good. So it's a really good question. And everything I'm talking about here is predicated on using AI to do admissions. So here, if you don't use AI and you got rid of test scores, things could get, things would likely look very different, or at least would look more different than what I suggested here. Because these subtle signals are not things that humans necessarily are going to pick up exam. Okay. And so everything here is predicated on using AI. So after we did this work, we piloted AI admissions, AI informed admissions. And so this is AI assistant, and so this is some work that's going to come out pretty soon. But we exactly, we put our money where our mouth was. We're like, look, it's like we think AI can help in this admissions process. It's going to lead to more consistent decisions, more equitable decisions. It can lead to higher quality cohorts of classes. And so we took that evidence and we built a pipeline to help admissions officers make these types of decisions using these types of AI-based. Now, humans are still in the loop. And everything is like, every application is read by a human, and at the same time, they have the benefit of these very subtle signals that are being extracted from transcripts, from essays, from resumes, recommendation, all of these things that humans might miss in favor of just looking at that test score. It's like this big shiny object of the test score. And we can say it's like, well, there's all this other information. So let's consider all of it holistic. So look for that paper, will come out in the next couple months, but that's exactly what I think of it. Me too. Fine.
Would you mind just quickly give me some how it's done like in practice? Is that like done like side by side, like admissions officer reading this essay and it's going over to a different tab? It's like, okay,
Yeah.
well, this is what I thought would be.
So here, the quick version of it, and this is kind of common in a lot of institutions, is we have multiple reads. And so you might have, like around one read, around two read, and then maybe some high bake around later. And so we replace one of those human reads with an AI, but everything else about the process is.
Okay, I just have follow-up questions for what you said. And you mentioned that you go to a pipeline where you put AI. That's an example of how.
Why, what is it?
Yeah, well, yeah, what that.
Yeah, here, so the idea is, we actually had yet another paper coming out on this pipe. So a lot of my work is on, building and yeah, and so we had to develop, I can not tell you all the details, but we can develop techniques behind the hood to actually use AI to help make these decisions, because the kind of conventional wisdom is algorithms could inflate biases. And so we developed a new procedure for training these algorithms that could reduce biases. And the quick answer is, why does this work? Well, if we assume that admissions officers are biased, have implicit biases, like many people do, then that is going to be reflected in the decision. So you take an extreme example, you take, let's say the exact same test score, and now they're going to give, higher ratings to applicants from one group or another, and those higher ratings are going to translate to an increased probability of being from that. Like that's like the human story. Now the AI story is if you train the models correctly, and it's like using this approach that we developed, then that issue will be mitigated in the because you're saying it's like, here's a test score, and here's my decision based on this test score. And if you're perfectly grounded in an observable outcome, like downstream grades, then you can say it's that here is my statistically optimized prediction of grade that doesn't use things, it's like, it doesn't care about things like race or gender or other things that might bias decision making. It's like, this is the thing that I'm going to optimize in my decision making for. And now the hope is to get more consistent and also it's a big question though.
Right.
And but that's like the intuition. But again, look out for things. Really.
Yeah, I'm actually going back to the first part of the talk where you're students using AI in their essays, and I noticed there were a couple like clear temporal trends, like more students are using it over time. And also it looked like the quality of the AI written essays were getting better over time. I assume the models were getting better and since you're getting better at AI. So I'm curious if you noticed any temporal trends with this kind of preference for this for getting students who weren't using it, if you expect that to change over time, or if there was any temporal pattern.
Yeah, so it's a good question. So one thing to be careful about is I think the quality of the models is getting better, significantly better. That's like my anecdotal take on these things. But what you were seeing in the plots, this was not conditioning on data heaps, it was just like, the trends before and after. So a lot of that was because adoption is. And so the average quality of essays was improving in large part because more people were using AI, and AI makes your essays. And so that's just like one thing to be careful about in that type of analysis. Sorry, I think I missed. What was the second?
The question was basically were there in this sort of noting that there's this kind of preference for admitting students.
Oh, okay. So the preference, yeah.
Is that
So okay, yeah. So this is so I do think that these things are going to change. They're part of the people who grapple with these policies. And in fact, it's a school that the program that we're studying here. Once we took these types of results to admissions officers, we contaminated them. Because now they're like looking at every essay and thinking AI, not AI. So we actually had to like throw that out in this second analysis where we're like all sorts of funny things. We changed the admission process. So be very careful when you do. But it is true. It's like something that we worried about is it's like the mere observation of the author effect here, that we were like changing the process by observing the process and telling them what they were doing. And in fact, like the plot where we like validated that they kind of could tell it was AI, we were really afraid of showing them that plot because people look at that and they're just like, oh yeah, I'm like an AI, human AI. And it's like, that is not true. We are not a human AI sector. It's like, you are like, you can tell better than chance, but you are not an AI sector, and you probably shouldn't be penalizing students based on a gut reaction. Like that's exactly where the biases could come in, especially for international applications. This is something that we worry about, where you're like, oh, it's like this writing is like too good for somebody from this country. I would just assume it's AI and I'll reject it. The model itself wouldn't do that. But I do think norms, attitudes around this is a change.
Just one final question. So maybe the question from Zoom, a couple people are asking about if there's discussions that are being had around GPA as an indicator of success, like are there other indicators that you're looking at in terms of what makes something successful at a university?
Yeah, so it's a really good question. And so there are kind of two answers. So first is, specifically quantitative GREs is the thing in the literature that is looked at when we are considering test scores. Like that is, test scores, the predictive power of test scores is really coming from the ability to predict that type of outcome. And so this entire analysis was shaped by running the comparison to give test scores the best shot. We're saying it's like, let's play the game the way it was designed to be played to make sure that we are not underselling the value of test scores. Now, that being said, what actually happens is that test scores are not the end all of what it means to succeed. And particularly in policy schools, a lot of schools, including the program that we're looking at, care about public service, like sort of a mission orientation, leadership, all of these types of things. So what we did is we ran another analysis where we tried to recreate the actual utility function of admissions officers, for which grades are one part of it, but all these other things are a big part of that mix. So again, the same way that we the rubrics, we can look at past decisions and we can reverse engineer what two admission officers ultimately care about. And grades are a big part, but not everything. And then we run the exact same comparison about with test scores and without test scores, we would mix these cohorts based on the utility to optimize utility function that admissions officers seem to care about, and everything shrinks as expected. And so then, that 0.03 shrinks to about 0.02, right? So everything is going to shrink because now it's like test scores are predictive at quantitative grades. They're not super predictive of whether or not you are, going to work in a policy setting in the future. Do you have this mission orientation? And so here, everything is an upper bound on what is likely to play out in the world. So there's one question. I don't know if you have something.
So I was curious, in thinking about the potential costs that you slide that still up mentioned, one of the things people talk about with testing is research on stereotype threats. And so imagining a specific underrepresented groups, marginalized groups being kind of penalized by the kind of testing effect and perceptions of intelligence that come along with that. So is there a way to start modeling and imagining what are the consequences for our schools if we assume a certain stereotype threat impact on some portion of the applicant pool, and then who are we losing out of it? I mean, I think that's been the big question admissions programs have had around the years. So.
Yeah, I think it's a great question. It's not, I say, the terrific summary of some of the costs that people flag here. And I don't know. I do think especially in these test optional years, people have looked at the composition of pools and all that. So I think we can go in that direction. But it's interesting, and that has always been my kind of thought about this debate, my informal thought was look, if people are talking about the benefits, we're not really talking about the cost. So it's very hard to make the informed decision. What's interesting about this work is we're saying the benefits seem to be quite small. And so if the costs are more than negligible, that in my mind pushes us towards a test optional world. But again, in theory, the cost might be minuscule. It's totally possible. And so we still have a bit of ambiguity, but in that world, maybe it doesn't matter. Like, it's like test optional, not test optional, it probably doesn't matter if we're in that world, but it's plausible in the world with cluster high, and then you see that. So it's a good question. I don't have any direct work on it, but I think that's a great. Okay. Thanks, everybody.
Thank you.
Kenny, I'm gonna take you, and you have a meeting.